Boeing 777. 777 and B777 redirect here. For the road in Scotland, see B777 road. For other uses, see 777 disambiguation. The Boeing 777, commonly referred to as the 777, is an American long-range wide-body airliner developed and manufactured by Boeing Commercial Airplanes. The 777 is the world's largest twin jet and most built wide-body airliner. The jetliner was designed to bridge the gap between Boeing's other wide-body airplanes, the twin-engine 767 and quad-engine 747, and to replace aging DC-10 and L-10-11 trijets. Developed in consultation with 8 major airlines, the 777 program was launched in 1990 with an order from United Airlines. The prototype aircraft rolled out in April 1994 and first flew in June of that year. The 777 entered service with the launch operator United Airlines in June 1995. Longer-range variants were launched in 2000 and first delivered in 2004. The 777 can accommodate a 10 abreast seating layout and has a typical 3-class capacity of 301 to 368 passengers with a range of 5,240 to 8,555 nautical miles (NMI), 9,700 to 15,840, that is 9,700 to 15,840 kilometers, or 6,030 to 9,840 miles. The jetliner is recognizable for its large diameter turbofan engines, raked wingtips, 6 wheels on each main landing gear, fully circular fuselage cross-section, and a blade-shaped tail cone. The 777 became the first Boeing airliner to use fly-by-wire controls and to apply a carbon composite structure in the tailplanes. The original 777, with a maximum takeoff weight (MTOW) of 545,000 to 660,000 pounds, that is 247 to 299 tons, was produced in 2 fuselage lengths. The initial 777-200 was followed by the extended range 200ER in 1997, and the 33.25 feet, 10.13 meters longer 777-300 in 1998. These have since been known as the 777 Classics and were powered by 77,200 to 98,000 lbf, that is 343 to 436 kN, General Electric GE90, Pratt & Whitney PW4000 or Rolls-Royce Trent 800 engines. The extended range 777-300ER with an MTOW of 700,000 to 775,000 pounds, 380 to 352 tons, entered service in 2004. The longer range 777-200LR in 2006 and the 777F freighter in 2009. These second generation 777 variants have extended raked wingtips and are powered exclusively by 110,000 to 150,000 lbf, that is 489 to 513 kN, GE90 engines. In November 2013, Boeing announced the development of the third generation 777X. The variants include the 777-8, 777-9, and 777-8F, featuring composite wings, folding wingtips, and General Electric GE9X engines, and slated for first deliveries in 2026. As of 2018, Emirates was the largest operator with a fleet of 163 aircraft. As of December 2024, more than 60 customers have placed orders for 2,303 777s across all variants, of which 1,741 have been delivered. This makes the 777 the best-selling wide-body airliner, while its best-selling variant is the 777-300ER, with 833 delivered. The airliner initially competed with the Airbus A340 and the McDonnell Douglas MD-11. Since 2015, it has mainly competed with the Airbus A350. First-generation 777-200 variants are to be supplanted by Boeing 787 Dreamliner. As of May 2024, the 777 has been involved in 31 aviation accidents and incidents, including 5 hull loss accidents out of 8 total hull losses, with 542 fatalities, including 3 ground casualties. Boeing 777. The first Boeing 777 built, 777-200B H&L, in operation in July 2011 by then owner Cathay Pacific. General information. Wide-body jet airliner. National origin, United States. Manufacturer, Boeing commercial airplanes. Status, in service. Primary users, Emirates, United Airways, Qatar Airways, Air France. Number built, 1741 as of December 2024 based on deliveries. History, manufactured 1993 to the present. Introduction date, June 7, 1995 with United Airlines. First flight, June 12, 1994, 30 years ago. Developed into Boeing 777X. Development. Background. In the early 1970s, the Boeing 747, McDonnell Douglas DC-10 and the Lockheed L-1011 TriStar became the fourth generation of wide-body passenger airliners to enter service. In 1978, Boeing unveiled three new models: the twin-jet or twin-jet Boeing 777, later named Boeing 757, to replace its 727, the twin-jet Boeing 7X7, later named 767, to challenge the Airbus A300, and the tri-jet 777 concept to compete with the DC-10 and L-1011. The mid-size 757 and 767 launched to market success due to in part a 1980s extended range twin-engine operational performance standards (ETOPS) regulations governing transoceanic twin-jet operations. These regulations allow twin-engine airliners to make ocean crossings at up to 3 hours distance from emergency diversionary airports. Under ETOPS rules, airlines began operating the 767 on long-distance overseas routes that did not require the capacity of larger airliners. The tri-jet 777 was later dropped, following our marketing studies that favored the 757 and 767 variants. Boeing was left with the size and range gap in the product line between the 767-300ER and the 747-400. By the late 1980s, DC-10 and L-1011 models were expected to be retired in the next decade, prompting manufacturers to develop replacement designs. McDonnell Douglas was working on the MD-11, a stretched successor of the DC-10, while Airbus was developing its A330 and A340 series. In 1986, Boeing unveiled proposals for an enlarged 767, tentatively named 767X, to target the replacement market for first-generation wide-bodies such as the DC-10, and to complement the existing 767, along with winglets. What the fuck? Is this shit gonna... By the late 1980s, DC-10 and L-1011 models were expected to be retired in the next decade, prompting manufacturers to develop replacement designs. McDonnell Douglas was working on the MD-11, a stretched successor of the DC-10, while Airbus was developing its A330 and A340 series. In 1986, Boeing unveiled proposals for the enlarged 767, tentatively named 767X, to target the replacement market for first-generation wide-bodies such as the DC-10, and to complement the existing 767 and 747 models in the company lineup. The initial proposal featured a longer fuselage and larger wings than the existing 767, along with winglets. Later plans expanded the fuselage cross-section, but retained the existing 767 flight deck, nose, and other elements. However, airline customers were uninterested in the 767X proposals and instead wanted an even wider fuselage cross-section, fully flexible interior configurations, short to intercontinental range capacity, and operating costs lower than that of any 767 stretch. Airline planners' requirements for the larger aircraft have become increasingly specific and due to the heightened competition among aircraft manufacturers. By 1988, Boeing realized that the only answer was a clean sheet design, which became the twin-jet 777. The company opted for the twin-jet engine configuration, given past design successes, projected engine developments, and reduced cost benefits. On December 8, 1989, Boeing began issuing offers to the airlines for 777. Design effort. Alan Mullally served as the Boeing 777 program's Director of Engineering and then was promoted in September 1992 to lead as his Vice President and General Manager. The design phase of the all-new twin-jet was different from Boeing's previous jetliners. 8 major airlines, All Nippon Airways, American Airlines, British Airways, Cathay Pacific, Delta Airlines, Japan Airlines, Qantas, and United Airlines played a role in the 777 development. This was a departure from industry practice, where manufacturers typically designed aircraft with minimal customer input. The 8 airlines that contributed to the design process became known within Boeing as the Working Together Group. At the group's first meeting in January 1990, a 23-page questionnaire was distributed to the airlines, asking what each wanted in its design. By March 1990, the group had decided upon a baseline configuration. A cabin cross-section includes the 747s, capacity up to 325 passengers, flexible interiors, a glass cockpit, a fly-by-wire controls, and a 10% better seat mile cost than the Airbus A330 and the McDonnell Douglas MD-11. The two-crew glass cockpit uses fly-by-wire controls. The development phase of the 777 coincided with United Airlines' replacement program for its aging DC-10s. On October 14, 1990, United became the first launch customer with an order for 34 Pratt & Whitney powered 777s valued at US $11 billion, that is $22.7 billion in 2023, and options for 34 more. The airline required the new aircraft be capable of flying 3 different routes: Chicago to Hawaii, Chicago to Europe, and non-stop from Denver, a hot and high airport, to Hawaii. ETOPS certification was also a priority for United, given the overwater portion of United's Hawaii routes. In late 1991, Boeing selected its Everett factory in Washington, home of the 747 and 787 production, as the 777's final assembly line, FAL. In January 1993, a team of United developers joined other airline teams and Boeing designers at the Everett factory. 240 design teams, up to 40 members each, addressed almost 1,500 design issues with individual aircraft components. The fuselage diameter was increased to suit Cathay Pacific. A baseline model grew longer for All Nippon Airways, and British Airways input led to added built-in testing and interior flexibility, along with higher operating weight options. The 777 was the first commercial aircraft to be developed using an entirely computer-aided design, CAD process. Each design drawing was created on a 3-dimensional CAD software known as CATIA, sourced from Dassault Systems and IBM. This allowed engineers to virtually assemble the 777 aircraft on a computer system to check for interference and verify that the thousands of parts fit properly before the actual assembly process, thus reducing costly rework. Boeing developed its high-performance visualization system, Fly-Through, later called IVT, Integrated Visualization Tool, to support large-scale collaborative engineering design reviews, production illustrations, and other uses of CAD data outside of engineering. Boeing was initially not so convinced of CAT's abilities and built a physical mock-up of the nose section to verify the results. The test was so successful that all additional mock-ups were cancelled. The 777 was completed with such precision that it was the first Boeing jetliner that did not require the details to be worked out on an expensive physical aircraft mock-up. This had the design process to limit cost to a reported $5 billion USD. Testing and certification. Major assembly of the final aircraft began on January 4, 1993. On April 4, 1994, the first 777, number WA001, was rolled out in a series of 15 ceremonies held during the day to accommodate the 100,000 invited guests. The first flight took place on June 12, 1994, under the command of Chief Test Pilot John E. Cashman. This marked the start of an 11th month flight test program that was more extensive than testing for any other previous Boeing model. 9 aircraft with General Electric, Pratt & Whitney, and Rolls-Royce engines were flight tested at locations ranging from the desert airfield at the Edwards Air Force Base in California to frigid conditions in Alaska, mainly the Fairbanks International Airport. To satisfy ETOPS requirements, 8 180-minute single-engine flight tests were performed. The first aircraft built was used by Boeing's non-destructive testing campaign from 1994 to 1996 and provided data with the 200 ER and 300 programs. The successful conclusion of flight testing, the 777 was awarded simultaneous airworthiness certification by the U.S. Federal Aviation Administration (FAA) and European Joint Aviation Authorities (JAA) on April 19, 1995. The 777 made its maiden flight on June 12, 1994. Entry into service. Boeing developed the first 777 to United Airlines on May 15, 1995. The FAA awarded 180-minute ETOPS clearance, ETOPS 180, for the patent with the PW4084 engined aircraft on May 30, 1995, making it the first aircraft to carry an ETOPS 180 rating at its entry into service. The first commercial flight took place on June 7, 1995, from London Heathrow Airport to Dulles International Airport near Washington, D.C. Longer ETOPS clearance of 207 minutes was approved in October 1996. On November 12, 1995, Boeing delivered the first model with General Electric GE90 77B engines to British Airways, which entered service 5 days later. Initial service was affected by gearbox bearing wear issues, which caused British Airways to temporarily withdraw its 777 fleet from transatlantic service in 1997, returning to full service later that year. General Electric subsequently announced engine upgrades. The first Rolls-Royce Trent 877 powered aircraft was delivered to Thai Airways International on March 31, 1996, completing the introduction of the three power plants initially developed for the airliner. Each engine aircraft combination had secured ETOPS 180 certification from its entry into service. By June 1997, orders for the 777 number 323 from 25 airlines, including launch customers, had ordered additional aircraft. Operations performance data established by the consistent capabilities of the twin jet over long-haul transoceanic routes leading to additional sales. By 1998, the 777 fleet had approached more than 900,000 flight hours. Boeing states that the 777 fleet had a dispatch reliability rate of departure from the gate no more than 15 minutes delay due to technical issues above 99%. On May 15, 1995, United Airlines received the first Boeing 777-200 and made the first commercial flight on June 7th. Improvements and stretching 200ER to 300. After the baseline model, the 777-200, Boeing developed an increased gross weight variant with greater range and payload capability. Initially named the 777-200 IGW, the 777-200ER first flew on October 7, 1996, received FAA and JAA certification on January 7, 1997, and entered service with British Airways on February 9, 1997. Offering greater long-haul performance, the variant became the most widely ordered version of the aircraft through the early 2000s. On April 2, 1997, a Malaysia Airlines 200ER named Super Ranger took the Great Circle distance without landing record to the airliner by flying eastward from Boeing Field, Seattle to Kuala Lumpur, a distance of 10,823 nautical miles, 20,044 kilometers, 12,455 miles in 21 hours and 23 minutes. Following the introduction of the 200ER, Boeing turned its attention to a stretched version of the baseline model. On October 16, 1997, the 777-300 made its first flight. At 242.4 feet, 73.9 meters in length, the 300 became the longest airliner yet produced until the A340-600 had a 20% greater overall capacity than the standard length model. The 300 was awarded type certification simultaneously from the FAA and JAA on May 4, 1998, and ended service to launch customer Cathay Pacific on May 27, 1988. The Cathay Pacific introduced the stretched 300 variation on May 27, 1998. The first generation of the Boeing 777 models, 200, 200ER, and 300 have since been known collectively as the Boeing 777 Classics. These three early 777 variants had three engine options ranging from 77,200 to 98,000 lbf, 343 to 436 kN, General Electric GE90, Pratt & Whitney PW4000, or Rolls-Royce Trent 800. Production. The production process included substantial international content, an unprecedented level of global subcontracting for the Boeing jetliner, later exceeded by the 787. International contributors included Mitsubishi Heavy Industries and Kawasaki Heavy Industries, fuselage panels, Fuji Heavy Industries Limited, center wing section, Hawker de Havilland elevators, and Aerospace Technologies of Australia, rudder. An agreement between Boeing and the Japan Aircraft Development Corporation, representing Japanese aerospace contractors, made the latter risk-sharing partners for 20% of the entire development program. To accommodate production of the new airliner, Boeing doubled the size of the Everett factory at the cost of nearly USD 1.5 billion, that is USD 2.86 billion in 2023, to provide space for two new assembly lines. New production methods were developed, including a turn machine that could rotate fuselage subassemblies 180 degrees, giving workers access to upper body sections. By the start of production in 1993, the program had amassed 118 firm orders, with options of over 95 more from 10 airlines. Total investment in the program was estimated at over USD 4 billion from Boeing, with an additional USD 2 billion from suppliers. Initially, second to 747 as Boeing's most profitable jetliner, the 777 became the company's most lucrative model in the 2000s. An analysis published by the 777 program, assuming Boeing has fully recovered the plane's development costs, may account for USD 400 million of the company's pre-tax earnings in 2000, USD 50 million more than the 747. By 2004, the aircraft accounted for the bulk of wide-body revenues for Boeing commercial airplanes. In 2007, orders for the second-generation 777 models approached 350 aircraft. In November of that year, Boeing announced that all production slots were sold out to 2012. The program backlog of 356 orders was valued at USD 95 billion at list prices in 2008. The Boeing Everett factory was expanded with two new FLAs to accommodate 777 production. In 2010, Boeing announced plans to increase production from 5 aircraft per month to 7 aircraft per month by mid-2011 and 8.3 per month by early 2013. In November 2011, assembly of the 1777 300ER began, and it took 49 days to fully assemble one of those variants. The aircraft in question was built for the Emirates airline and rolled out of the production facility in March 2012. By the mid-2010s, the 777 had become prevalent on the longest flights internationally and had become the most widely used airliner for trans-Pacific routes, with variants of the type operating over half of all scheduled flights, with the majority of the airliner used for trans-Pacific carriers. By April 2014, the cumulative sales surpassing those of the 747, the 777 became the best-selling wide-body airliner. At existing production rates, the aircraft was on track to become the most delivered wide-body airliner by mid-2016. By February 2015, the backlog of undelivered 777s totaled 278 aircraft, equivalent to nearly 3 years at the then production rate of 8.3 aircraft per month, causing Boeing to ponder the 2018-2020 timeframe. In January 2016, Boeing confirmed plans to reduce the production rate of the 777 family from 8.3 per month to 7 per month in 2017 to help close the production gap between the 777 and 777X due to a lack of new orders. In August 2017, Boeing was scheduled to drop 777 production again to 5 per month. In 2018, assembling test 7779 aircraft was expected to lower output to an effective rate of 5.5 per month. In March 2018, as previously predicted, the 777 overtook the 747 as the world's most produced wide-body aircraft. Due to the impact of the COVID-19 pandemic on aviation, demand for new jets fell in 2020, and Boeing further reduced monthly 777 production from 5 to 2 aircraft. Second generation 777X 300ER 200LR F. From the program start, Boeing had considered building an ultra-long-range variant. Early plans centered on a 777-100X proposal, a shortened variant of the 200 with reduced weight and increased range, similar to the 747 SP. However, the 100X would have carried fewer passengers than the 200 while having similar operating costs, leading to a higher cost per seat. In the late 1990s, design plans shifted to a longer-range versions of the existing models. In March 1997, the Boeing board approved the 777-200X 300X specifications, 298 passengers in 3 classes, over 8,600 nmi, 15,900 kilometers, to 9,900 miles with the 200X, and 6,600 nmi, 12,200 kilometers or 7,600 miles with 355 passengers and a tri-class layout for the 300X with the design freeze planned in May 1998, 200X certification in August 2000, and introduction in September and in January 2001 for the 300X. The 4.5 feet 1.37 meter wider wing was to be strengthened and the fuel capacity enlarged, and it was to be powered with simple derivatives with similar fans. GE was proposing a 102,000 lbf 454 GE90 102B, while P&W offered its 98,000 lbf 436 kN PW 4098, and RR was proposing a 98,000 lbf 437 kN Trent 8102 or the 100,000 lbf 445 kN. Boeing was also studying a semi-levered, articulated main gear to help the takeoff rotation of the proposed 300X with its higher 715,600 pound, 324,600 kg MTOW. By January 1999, its MTOW grew to 750,700 pounds, 340,500 kg, and thrust requirements increased to 110,000 to 114,000 lbf, 490 to 510 kN. A more powerful engine in the thrust class of 100,000 lbf, 440 kN was required, leading to talks between Boeing and engine manufacturers. General Electric offered to develop the GE90 115B engine, while Rolls-Royce proposed developing the Trent 8104 engine. In 1999, Boeing announced an agreement with General Electric, beating out rival proposals. Under the deal of General Electric, Boeing agreed to offer only GE90 engines on new 777 versions. On February 29, 2000, Boeing launched its next-generation twin-jet program, initially called 777X, and began issuing offers to airlines. Development was slowed by an industry downturn during the early 2000s. The first model to emerge from the program, the 777-300ER, was launched with an order of 10 aircraft from Air France, along with additional commitments. On February 24, 2003, the 300ER made its first flight, and the FAA and EASA, European Aviation Safety Agency, successor to the JAA, certified the model on March 16, 2004. The first delivery to Air France took place on April 29, 2004. The 300ER, combined the 300's added capacity for the 200ER range, became the top-selling 777 variants in the late 2000s, benefiting as airlines replaced comparable 4-engine models with twin jets for the lower operating costs. The more powerful GE90 engine of later variants has a 128-inch, 330 cm diameter fan, up from 123 inches, 310 cm, in early variants, and curved blades instead of straight ones. The second long-range model, 777-200LR, rolled out on February 15, 2005, and completed its first flight on March 8, 2005. The 200LR was certified by both the FAA and EASA on February 2, 2006, and the first delivery to Pakistan International Airlines occurred on February 26, 2006. On November 10, 2005, the first 200LR set a record for the longest non-stop flight of a passenger airliner by flying 11,664 nautical miles, 21,602 kilometers, 13,423 miles eastward from Hong Kong to London. Lasting 22 hours and 42 minutes, the flight surpassed the 200LR standard design range and was logged in the Guinness World Records. The production freighter model, the 777F, rolled out on May 23, 2008. The maiden flight of the 777F, which used the structural design and engine specifications of the 200LR, along with fuel tanks derived from the 300ER, occurred on July 14, 2008. FAA and EASA type certification for the freighter was received on February 6, 2009, and the first delivery to launch customer Air France took place on February 19, 2009. Air France received the first 777-300ER on April 29, 2004. By the late 2000s, the 777 was facing increased potential competition from Airbus planned A350 XWB and internally from the proposed 787 series. Both airliners are offer fuel efficiency improvements. As a consequence, the 777-300ER received engine and aerodynamics improvement packages for reduced drag and weight. In 2010, the variant furthered a 5,000 pound, 2,300 kg maximum zero fuel weight increase, equivalent to a higher payload of 20 to 25 passengers. Its GE90 115B1 engines received a 1 to 2.5% thrust enhancement for increased takeoff weights at higher altitude airports. Through these improvements, the 777 remains the largest twin-jet airliner in the world. In 2011, the 787 Dreamliner entered service that completed first stage, aka the Yellowstone 2 Y2 of a replacement aircraft initiative called the Boeing Yellowstone Project, which would replace large variants of the 767, 300, 300ER, 400, but also small variants of the 777, 200, 200ER, 200LR, while the large variants of the 777, 300, 300ER, as well as 747 could eventually be replaced by a new generation aircraft. Yellowstone 3 Y3 should draw upon technologies from the 787 Dreamliner Y2. More changes were targeted for late 2012, including possible extension of the wingspan, along with other major changes, including a composite wing, a new generation engine, and different fuselage lengths. Emirates was reportedly working closely with Boeing on the project, in conjunction with a potential launch customer for the new 777 generation. Among customers for the aircraft during this period, China Airlines ordered 10 777-300ER aircraft to replace 747-400s on long-haul trans-Pacific routes, with first of those aircraft entering service in 2015, noting that the 777-300ER's per-seat cost is about 20% lower than that of 747 costs, varying due to file prices. Improvement packages. In tandem with the development of the third-generation Boeing 777X, Boeing worked with General Electric to offer a 2% improvement in fuel efficiency to in-production 777-300ER aircraft. General Electric improved the fan module and the high-pressure compressor Stage 1 blisk in the GE90 115 turbofan, as well as reduced clearances between the tips of the turbine blades and the shroud during cruise. These improvements, of which the latter is the most important and was derived from work to develop the 787, was stated by GE to lower fuel burn by 0.5%. Boeing's wing modifications were intended to deliver the remainder. Boeing stated that every 1% improvement in the 777-300ER's fuel burn translates into being able to fly the aircraft for another 75 nmi, 139 kilometers, 86 miles, with the same load of fuel, or at 10 passengers, or 2,400 pounds, 1,100 kg of cargo to a load-limited flight. In March 2015, additional details of the improvement package were unveiled. The 777-300ER was to shed 1,800 pound to 820 kg by replacing the fuselage crown with tie rods and composite integration panels, similar to those used on the 787. The new flight control software will eliminate the need for the tail skid by keeping the tail off the runway surface regardless of the extent to which pilots would command the elevators. Boeing was also redesigning the inboard flap fairings to reduce drag by reducing pressure on the underside of the wing. The outboard raked wingtip was to have a divergent trailing edge, described as a poor man's airfoil by Boeing. This was originally developed for the McDonnell Douglas MD-12 project, and under change in the improved elevator trim bias, these changes were to increase fuel efficiency and allow aircrafts to add 14 additional seats to the aircraft, including per-seat fuel efficiency by 5%. Mindful of the long time required to bring the 777X to the market, Boeing continued to develop improvement packages, which improve fuel efficiency as well as lower prices for the existing aircraft. In January 2015, United Airlines ordered 10 777-300ERs, normally selling for around 150 million USD per aircraft, which it purchased for 130 million USD each, a discount to bridge the production gap to the 777X. In 2019, the list price for the 200ER was close to 306.6 million, The 200LR was close to 346.9 million USD. The 300ER close to 375.5 million USD, and the 777F with 352.3 million USD. The 200ER is the only classic variant listed. Third generation 777X 8, 8F, 9. Main article Boeing 777X. In November 2013, with orders and commitments totaling 259 aircraft from Lufthansa, Emirates, Qatar Airways, and Etihad, Boeing formally launched the 777X program. The generation of 777 with two models, 777-8 and the 777-9. The 777-9 is a further stretched variant with a capacity of over 400 passengers and a range of over 8,200 nmi, 15,200 kilometers, 9,400 miles. Whereas the 777-8 is slated to seat approximately 350 passengers and to have a range of over 9,300 nmi, 17,200 kilometers, 10,700 miles. Both models are to be equipped with the new generation GE9X engines and feature new composite wings and folding wingtips. The first member of the 777X family was projected to enter service in 2020 at the time of the program announcement. The rollout of the prototype of the 777X, a 777-9 model, occurred on March 13, 2019. 777-9 first flew on January 25, 2020. The deliveries initially forecasted for 2022 or 2023 and later delayed to 2025. The rollout of the third generation Boeing 777X on March 13, 2019, featuring composite wings with folding tips and more efficient GE9X engines. Design. Boeing introduced a number of advanced technologies for the 777 design, including fully digital fly-by-wire controls, fully software configurable avionics, Honeywell LCD glass cockpit flight displays, and the first use of fiber optic avionics network on a commercial airliner. Boeing made use work done of the cancelled Boeing 7J7 regional jet, which utilized similar versions of the chosen technologies. In 2003, Boeing began offering option of cockpit electronic flight pack computer displays. In 2013, Boeing announced that the updated 777X models would incorporate airframe systems and inferior technologies from the 787. The platform view for Boeing 777-300ER with raked wingtips. Fly-by-wire. In designing the 777 as the first fly-by-wire commercial aircraft, Boeing decided to retain conventional control yokes rather than to change to side-stick controllers as used in many fly-by-wire fighter aircraft and in many Boeing airliners. Along with traditional yoke and rudder controls, the cockpit features a simplified layout that retains similarities to previous Boeing models. The fly-by-wire system also incorporates the flight envelope production, a system that guides pilots' inputs within a computer-calculated framework of operating parameters, acting to prevent stalls, overspeeds, and excessively stressful maneuvers. This system can be overridden by the pilot if deemed necessary. The fly-by-wire system is supplemented by mechanical backup. Airframe and systems. The airframe incorporates the use of the composite materials, accounting for 9% of the original structural weight, with the third generation models, the 777-8 and the 777-9, feature more composite parts. Composite components include the cabin floor and rudder, with the 777 being the first Boeing airliner to use composite materials for both the horizontal and vertical stabilizers. Empennage. The main fuselage cross-section is fully circular and tapers rearward into a blade-shaped tail cone with a port-facing auxiliary powered unit. The wings of the 777 feature a supercritical airfoil design that is swept back at 31.6 degrees and optimized for cruising at Mach 0.83, revised after flight tests up to Mach 0.84. The wings are designed with increased thickness and longer span than previous airliners, resulting in greater payload and range, improved takeoff performance, and a higher cruising altitude. The wings also serve as fuel storage, with longer range models able to carry up to 47,890 US gallons, 181,300 liters of fuel. This capacity allows the 777-200LR to operate ultra-long distances, transport routes such as Toronto to Hong Kong. In 2013, a new wing made of composite materials was introduced for the upgraded 777X with wider span and design features based on the 787's wings. An Emirates 777-300ER in September 2009, showing the circular fuselage profile, dihedral wings, and GE90 turbofan engines, the largest jet engine in service until surpassed by the General Electric GE9X. Folding wingtips, 21 feet 6.40 meters long, were when offered when the 777 was first launched, to appeal to airlines who might use gates made to accommodate smaller aircraft. But no airline purchased this option. Folding wingtips re-emerged as a design feature at the announcement of the upgraded 777X in 2013. Smaller folding wingtips of 11 feet, 3.35 meters in length, will allow 777X models to use the same airport gates and taxiways as earlier 777s. These smaller folding wingtips are less complex than those proposed for earlier 777s and internally only affect the wiring needed for wingtip flights. 777-200ER of American Airlines in July 2007 with Trent 800 engines, extended slat flaps, and 6-wheel landing gear. External videos. Boeing 777 nose landing gear overview. The aircraft features the largest landing gear and biggest tires ever used in a commercial jetliner. The 6-wheel bogies are designed to spread the load of the aircraft over a wide area without requiring an additional centerline gear. This helps reduce weight and simplifies the aircraft's braking and hydraulic systems. Each side of a 777-300ER 6-wheel main landing gear can carry a load of 59,490 pounds, 26,980 kg. It is heavier than other wide bodies such as 747-400. The aircraft has triple redundant hydraulic systems with only one system required for landing. A ram air turbine, a small retractable device which can provide emergency power, is also fitted in the wing rule fairing. Interior. The original 777 interior, also known as the Boeing signature interior, features curved panels, large overhead bins, and indirect lighting. Seating options range from 4 to 6 abreast in first class, up to 10 abreast in economy. The 777's windows were the largest of any current commercial airliner until the 787, and measured 15 by 10 inches, 380 by 250 millimeters, for all models outside the 777-8 and 9. The cabin also features flexibility zones, which entails deliberate placement of water, electric, pneumatic, and other connection points throughout the interior space, allowing airlines to move seats, galleys, lavatories, and quickly and more easily when adjusting cabin arrangements. Several aircraft have been also fitted with VIP interiors for non-airline use. Boeing designed a hydraulically down toilet seat cover hinge that closes slowly. The economy cabin of a Etihad Boeing 777-300ER in a 333 layout. In February 2003, Boeing introduced overhead crew rest as an option on the 777. Located above the main cabin and connected via staircases, the forward flight crew rest contained 2 bunks and 2 seats, while the aft cabin crew rest features multiple bunks. The signature interior has been adapted for other Boeing wide-body and narrow-body aircraft, including 737NG, 747-400, 757-300, and newer 767 models, including all 767-400ER models. The 747-8 and 767-400ER have also adopted the larger, more rounded windows of the original 777. The Royal Laurel class business class cabin in a 1-to-1 reverse herringbone layout on EVA Air 777-300ER. In July 2011, Flight International reported that Boeing was considering replacing the signature interior on the 777 with a new interior similar to that on the 787, as a part of a move towards a more common cabin experience across all Boeing platforms. With the launch of the 777X in 2013, Boeing confirmed that the aircraft would be receiving a new interior featuring 787 cabin elements and larger windows. Further details released in 2014 included reduced cabin side walls for greater interior room, noise damping technology, and higher cabin humidity. Air France has a 777-300ER sub-fleet has 472 seats each, more than any other international 777, to achieve a cost per available seat kilometer (CASK) around Euros 0.5. Similar to levels 314-seat Airbus A330-200, its benchmark low-cost long-haul. Competing on similar French overseas department destinations, Air Caraïbes has 389 seats on the A350-900 and 429 on the 1000. French Bees is even more dense with its 411 seats A350-900 due to 10 abreast accommodity seating, reaching Euros CASK of 0.4 according to Air France, and lower again with 480 seats on the 1000. Engines. The initial 777 models, consisting of 777-200, 777-200ER, 777-300, were launched with proportional options from three manufacturers: GE Aviation, Pratt & Whitney, and Rolls-Royce, giving the airlines their choice of engines from competing firms. Each manufacturer agreed to develop an engine in the 77,200 to 98,000 lbf 343 to 436 kN of thrust class for the world's largest twin jet, resulting in a General Electric GE90, Pratt & Whitney PW4000, or Rolls-Royce Trent 800 engines. The Trent 800 is the lightest of the power plants, as it weighs 13,400 pounds, 6,878 tons dry, while the GE90 is 17,400 pounds, 7.89 tons, and the PW4000 is 16,260 pounds, 7.38 tons. Initial 777 engine options: Pratt & Whitney PW4000, Rolls-Royce Trent 800, General Electric GE90-94B with its thrust reverser deployed. For Boeing second generation 777 variants, 777-300ER, 777-200LR, and 777F, greater thrust was needed to meet the aircraft requirements, and GE was selected as the exclusive engine manufacturer. The higher thrust variants, GE90-110B1 and 115B, have a different architecture from that of the earlier GE90 versions. GE incorporated an advanced larger diameter fan made from composite materials, which enhanced thrust at low flight speeds. However, GE also needed to increase core power and to improve net thrust at high flight speeds. Consequently, GE elected to increase core capacity, which they achieved by removing one stage from the rear of the HP compressor and adding an additional stage to the LP compressor, which more than compensated for the reduction in HP compressor pressure ratio, resulting in a net increase in core mass flow. The higher thrust GE90 variants are the first production engines to feature swept rotor blades. The nacelle has a maximum diameter of 166 inches, 4,200 millimeters. Each of the 22 fan blades on the GE90-115B have a length of 4 feet, 1.2 meters, and a mass of less than 50 pounds, 23 kilograms. General Electric GE90-115B. Variants. Boeing uses two characteristics: fuselage length and range, to define its 777 models. Passengers and cargo capacities varies by fuselage length. The 777-300 has a stretched fuselage compared to the base 777-200. Three range categories were defined. The A market would cover domestic and regional operations. The B market would cover routes from Europe to the US West, and the C market, the longest trans-Pacific routes. The A market would be covered by a 4,200 LMI, 7,800 km or 4,800 mile range, 516,000 pounds, 234 M2 aircraft for 353 to 374 passengers, powered by 71,000 lbf or 316 kN engines, followed by a 6,600 LMI, 12,200 kilometers or 7,600 miles B market range for 286 passengers in a 3 class with 82,000 lbf, 365 kN unit thrust and a 580,000 pounds, 263 tons of M2, and A340 competitor. Basis of an A market 409 to 434 passenger stretch and eventually a 7,600 nmi, 14,000 kilometers to 8,700 miles sea market of 90,000 lbf 400 kN engines. When referring to different variants, the International Air Transport Association IATA code collapses the 700 model designator and the 200-300 variant designator to 772 or 773. The International Civil Aviation Organization ICAO aircraft type designator system as a proceeding manufacturer letter, in this case B for Boeing, hence B772 or B773. Designations may append a range identifier like B77W for the 777-300ER by the ICAO, 77W for the IATA. Though the 200ER is a company marketing designation as not certificated as much, other notations include 773ER and 773B for the 300ER. 777-200. The initial 777-200 made its maiden flight on June 12, 1994 and was first delivered to United Airlines on May 15, 1995. With a 545,000 pound 247 M2 and 77,000 lbf 340 kN engines, it has a range of 5,240 nautical miles, 9,700 kilometers or 6,030 miles, with 305 passenger seats in a 3-class configuration. 200 was primarily aimed at US domestic airlines, though several Asian carriers and British Airways have also operated the type. 9 different 200 customers have taken delivery of the 88 aircraft, with 55 in airline service as of 2018. The competing Airbus aircraft was the A330-300. N774UA pictured in 2002, the second Boeing 777-200 produced. In March 2016, United Airlines shifted all of its operations with all 19 of its 200s to exclusively domestic US routes, including flights to and from Hawaii, and added more economy class seats by shifting to a 10 abreast configuration, a pattern that matched the American Airlines reconfiguration for the type. As of 2019, Boeing no longer presents the 200 as indicated by its removal from the manufacturer's price listings for the 777 variants. 777-200ER. The B market 777-200ER, ER for extended range, originally known as the 777-200 IGW, increased gross weight, has additional fuel capacity and an increased M2 enabling transoceanic routes, with a 658,000 pounds 298 M2 and 93,700 lbf 417 kN engines. It has a 7,065 nmi, 13,084 kilometers or 8,130 miles range with 301 passenger seats in a 3-class configuration. It was delivered first to British Airways on February 6, 1997. 33 customers received 422 deliveries, with no unit-filled orders as of 2019. As of 2018, 338 examples of the 200ER are in airline service. It competed with the A340-300. Boeing proposed the 787-10 to replace it. The value of a new 200ER rose from US dollars 110 million to service entry to US dollars 130 million in 2007. A 2007 model 777 was selling for US dollars 30 million 10 years later, while the oldest ones still had a value of around US dollars 5 to 6 million, depending on the remaining engine time. The 777-200ER entered service in February 1997 with the launch operator British Airways. The engine can be delivered T-rated with reduced engine thrust for shorter routes, lower the M2, reduce purchase price and landing fees as 777-200 specifications, but can be re-rated to full standard. Singapore Airlines ordered over half of its 200ERs D-rated. 777-200LR Worldliner. The 777-200LR Worldliner, LR for long range, sea market model entered service in 2006 as one of the longest range commercial airliners. Boeing named it Worldliner as it can connect almost any two airports in the world, although it is still subject to ETOPS restrictions. It holds the world record, the longest non-stop flight by a commercial airliner. It has a maximum design range of 8,555 nautical miles, that is 15,844 kilometers or 9,845 miles as of 2017. The 200LR was intended for ultra long haul routes such as Los Angeles to Singapore. A Boeing 777-200LR in the livery of its first operator, Pakistan International Airlines. Developed alongside the 300ER, the 200LR features an increased MTOW and 3 optional auxiliary fuel tanks in the rear cargo hold. New features include extended raked wing tips, redesigned main landing gear, and additional structural strengthening. As with the 300ER and 777F, the 200LR is equipped with wingtip extensions of 12.8 feet, 3.9 meters. The 200LR is powered by GE90 110B1 or GE90 115B turbofans. The first 200LR was delivered to Pakistan International Airlines on February 26, 2006. 12 different 200LR customers took delivery of the 61 aircraft. Airlines operated 50 of the 200LR variant as of 2018. Emirates is the largest operator of the LR variant with 10 aircraft. The closest competing aircraft from Airbus are the discontinued A340-500 HDW and the current A350-900 ULR. 777 Freighter. The 777 Freighter 777F is an all-cargo version of the twinjet and shares features with the 200LR. These include its airframe, engines, and fuel capacity. The 777F is unofficially referred to as the 777-200LRF by some cargo airlines. With a maximum payload of 228,700 pounds, that is 103,700 kg, similar to the 243,000 pound or 110,000 kg of the Boeing 747-200F. It has a maximum range of 9,750 nautical miles, that is 8,057 kilometers or 11,220 miles, or 4,907 nmi, that is 9,200 kilometers or 5,720 miles, at its max structural payload. A 777F of FedEx Express, the largest operator of the type. The 777F also features a new supernumerary area, which includes 4 business class seats forward of the rigid cargo barrier, full main tech access, bunks, and a gallery. As the aircraft promises improved operating economics compared to older freighters, airlines have said the 777F as a replacement for freighters such as the Boeing 747-200F, McDonnell Douglas DC-10, and McDonnell Douglas MD-11F. The first 777F was delivered to Air France on February 19, 2009. As of April 2021, 247 freighters have been ordered by 25 different customers, with 45 unfilled orders. Operators had 202 of the 777F in service as of 2018. 777-300 launched at the Paris Air Show on June 26, 1995. Its major assembly started in March 1997, and the body was joined on July 21st. It was rolled out on September 8 and made its first flight on October 16th. The 777-300 was designed to be stretched by 20%, 60 extra seats to a 368 in 3 class configuration, 75 more to 451 inches in 2 classes, or up to 550 in an all-economy like the 747SR. Also 33 feet, 10.1 meter stretch is done with 17 feet, 5.3 meters in 10 frames forward and 16 feet, 4.8 meters in 9 frames aft for a 242 feet, 73.8 meters length, 11 feet 3.4 meters longer. That's the 747-400. It uses the 200 ER, 45,200 US gallons, 171,200 liters fuel capacity, 84,000 to 98,000 lbf, 374 to 436 kN engines, with a 580,000 to 661,000 pounds, 263.3 to 299.6 M2. A 777-300 of Cathay Pacific, its launch operator. It has a ground maneuvering cameras for taxiing and a tail skid to rotate, while the proposed 716,000 pounds, 224.6 tons M2 300X would have needed a semi-levered main gear. Its overwing fuselage section 4.4 was strengthened, with its skin thickness going from the 200's 0.25 to 0.45 inches, 6.3 to 11.4 millimeters, and received a new evacuation door pair. Its operating empty weight, with the Rolls-Royce engines in typical tri-class layout, is 343,000 pounds, that is 155.72 tons, compared to 307,300 pounds, that is 139.38 tons, for a similarly configured 200. Boeing wanted to deliver 170 300s by 2006 and to produce 28 by the year 2002 to replace early Boeing 747s, burning one-third less fuel with 40% lower maintenance costs. With 660,000 pounds, 299-ton M2 and 90,000 lbf 400 kN engines, it has a range of 6,005 nautical miles, that is 11,121 kilometers or 6,910 miles, with 368 passengers in 3 classes. 8 different customers have taken delivery of 60 aircraft of the variant, of which 18 were powered by PW4000 engines and 42 by the RR Trent 800. None were ordered the GE90, which was never certified on this variant, with 48 in airline service as of 2018. The last 300 was delivered in 2006, with the longer-range 300ER started deliveries in 2004. 777-300ER. The 777-300ER, ER for extended range, is the B-market version of the 300. Its higher M2 and increased fuel capacity permits a maximum range of 7,370 nautical miles, 13,650 kilometers, or 8,480 miles, with 392 passengers in a 2-class seating arrangement. The 777-300ER features extended raked wingtips, a strengthened fuselage and wings, and a modified main landing gear. Its wings have an aspect ratio of 9. It is powered by the GE90 115B turbofan, the world's most powerful jet engine, the maximum thrust of 115,300 lbf, 513 kN. Following flight testing, aerodynamic refinements have reduced the fuel burn by an additional 1.4%. At Mach 0.839, 459 kN or 916 km per hour, FL300, negative 59 degrees Celsius, and at a 513,400 pound or 232.9 ton weight, it burns 17,300 pounds, 7.8 tons of fuel per hour. Its operating empty weight of 371,600 pounds or 168.6 tons. The projected operational empty weight is 371,610 pounds or 168,560 kilograms in aircraft configuration, at a weight of 477,010 pounds or 216,370 kilograms, and FL350, the total fuel flow is 15,000 pounds per hour or 6,790 kilograms per hour. At Mach 0.84, 459 kN or 917 kilometers per hour, rising to 19,600 pounds per hour or 8,890 kilograms per hour and Mach 0.87, that is 513 kn or 950 kilometers per hour. Since its launch, the 300ER had been a primary driver of the airplane's sales past the rival A330-340 series. Its direct competitors have included the Airbus A340 and 600 and the Airbus A350 and 1600. Using two engines produces a typical operating cost advantage of around 8 to 9%, the 300ER over the A340-600. Several airlines have acquired the 300ER as a 747-400 replacement amid rising fuel prices, given its 20% fuel burn advantage. The 300ER has an operating cost of $44 per seat an hour, compared to the Airbus A380's roughly $50 per seat hour and $90 per seat hour for a Boeing 747-400 as of 2015. The first 777-300ER was delivered to Air France on April 29, 2014. 300ER is the best-selling 777 variant, with Emirates being the largest operator with 123 777-300ER in service, having surpassed the 200ER in orders in 2010 and deliveries in 2013. As of 2018, 784 300ERs were in service. A total of 831 were built, the last delivered to Aeroflot in 2021. Boeing ended 777-300ER production in 2024 and switched to the new 777X. 777X. Main article: Boeing 777X. The third generation of the 777, launched as the 777X, is to feature new GE9X engines and new composite wings with folding wingtips. It was launched in November 2013 with two variants, the 777-8 and the 777-9. The 777-8 provides seating for 395 passengers and has a range of 8,745 nmi, or 16,196 kilometers, or 10,064 miles, while the 777-9 has seating for 426 passengers and a range of over 7,285 nmi, that is 13,492 kilometers, or 8,383 miles. A longer 777-10X, 777X Freighter, and 777X BBJ variants have also been proposed. Unveiling of the first 777X variant, the 777-9, on March 13, 2019. Government and corporate. Versions of the 777 have been acquired by government and private customers. The main purpose has been for VIP transport, including as air transport for the heads of state, although aircraft has been proposed for other military applications. 777 Business Jet, 777 VIP. The Boeing business jet variation of the 777 that is sold to corporate customers. Boeing has received orders for the 777 VIP aircraft based on the 777-200LR and the 777-300ER passenger models. The aircraft are filled with private jet cabins by third-party contractors, and the completion may take 3 years. A presidential flight of United Arab Emirates government 777-200ER. KC-777. This was a proposed tanker version of the 777. In September 2006, Boeing announced that it would produce the KC-777 if the United States Air Force USAF required a larger tank than the KC-767, able to transport more cargo or personnel. In April 2007, Boeing offered its 767-based KC-767 advanced tanker instead of the KC-777 to replace the smaller Boeing KC-135 Stratotanker under the USAF's KC-X program. Boeing officials have described the KC-777 as suitable for the related KC-Z program to replace the wide-body McDonnell Douglas KC-10 extender. In 2014, the Japanese government chose to procure two 777-300ERs to serve as the official air transport for the Emperor of Japan and the Prime Minister of Japan. The aircraft, operated by the Japan Air Self-Defense Force under the call sign Japanese Air Force One, entered service in 2019 and replaced two 747-400s. The 777-300ER was specifically selected by the Ministry of Defense owing to its similar capabilities to the preceding 747 pair. Besides VIP transport, the 777s were also intended for use in emergency relief missions. 777s are serving or have served as official government transports for nations including Gabon, VIP configured 777-200ER, Turkmenistan, VIP configured 777-200LR, and the United Arab Emirates, VIP configured 777-200ER, and 777-300ER operated by Abu Dhabi, a Mary flight. Prior to returning power as the Prime Minister of Lebanon, Rafik Hariri acquired a 777-300ER as official transport. The Indian government purchased two Air India 777-300ERs and converted them to VVIP transport operated by the Indian Air Force under the call sign Air India 1. They entered service in 2021, replacing the Air India owned 747s. A Japanese Air Self-Defense Force 777-300ER operating as Japanese Air Force One. In 2014, the UCAF examined the possibility of adopting modified 777-300ERs or 777-9Xs to replace the Boeing 747-200 aircraft used as Air Force One. Although the USAF had preferred a 4-engine aircraft, that was mainly due to precedent. Existing aircraft were purchased when the 767 was just beginning to prove itself with ETOPS. Decades later, the 777 and other twin jets established a comparable level of performance to quad-jet aircraft. Ultimately, the Air Force decided against the 777 and selected the Boeing 747-8 to become the next presidential aircraft. Aftermarket freighter conversions. In the 2000s, Boeing began studying the conversion of 777-200ER and 200 passenger airliners into freighters under the name 777 BCF, Boeing Converted Freighter. The company has been in discussion with several airline customers, including FedEx Express, UPS Airlines, and GE Capital Aviation Services, to provide launch orders for a 777 BCF program. 777-300ER Special Freighter SF. In July 2018, Boeing was studying a 777-300ER freighter conversion targeted for the volumetric market instead of the density market served by the production 777F. After having considered the 200ER P2F program, Boeing was hoping to conclude its study by the fall, as the 777X replaced aging 300ERs from 2020 will generate feedstock. New build 777-300ERs may maintain the delivery rate at 5 per month to bridge the production gap until the 777X is delivered. Within 811 777-300ERs delivered and 33 to be delivered by October 2019, GE Capital Aviation Services (GECAS) anticipates up to 150 to 175 orders through 2030. The 4 to 5 month conversion costing around $35 million USD. In October 2019, Boeing and Israel Aerospace Industries (IAI) launched the 777-300ER SF passenger to freighted conversion program, with GECAS ordering 15 aircraft and 15 options. The first aftermarket 777 freighter conversion program. In June 2020, IAI received the first 777-300ER to be converted from the GECAS. In October 2020, GECAS announced the launch. Operator from 2023, Michigan-based Kalita Air, already operating 24 747-400Fs, 9 767-300ERFs, and 3 777Fs. IAI should receive the first aircraft in December 2020, when certification and service entry was scheduled for late 2022. By March 2023, IAI had completed the first flight of a 777-300ER special freighter he converted for AirCap, as it had a backlog of over 60 orders. The 777-300ER special freighter has a maximum payload of 224,000 pounds, that is 101.6 tons, with a range of 4,500 nmi, that is 8,300 kilometers or 5,200 miles, and carries the door aperture and aft position of the 777F. It has a cargo volume of 28,900 cubic feet, that is 819 meters cubed, 5,800 cubic feet, that is 164 meters cubed, greater than the 777F, or 25% more, and can hold a 47 standard 96 times 125 in pallet P6P positions, 10 more positions than a 777F, or 8 more than a 747-400F. With windows plugged, passenger doors deactivated, fuselage and floor reinforced, and a main deck cargo door installed, the 777-300ER SF has 50% more volume than the 747-400 BCF. Experimental. Main article. Eco Demonstrator. Boeing has used 777 aircraft in 2 research and development programs. The first program, the Quiet Technology Demonstrator (QTD), was run in collaboration with Rolls-Royce and General Electric to develop and validate engine intake and exhaust modifications, including the chevrons subsequently used in 737 MAX, 747-8, and 767 series. The test was flown in 2001 and 2005. The 2022 Eco Demonstrator, a 777-200ER. A further program, the Eco Demonstrator series, is intended to test and develop technologies and techniques to reduce aviation's environmental impact. The program started in 2011, with the first Eco Demonstrator aircraft flying in 2012. Various airframes have been used since to test a wide variety of technologies in collaboration with a range of industrial partners. 777s have been used on 3 occasions as of 2024. The first of these, a 777F in 2018, performed the world's first commercial airliner flights using 100% sustainable aviation fuel, SAF. In 2022-4, the test bed is a 777-200ER. Operators. Main article. List of Boeing 777 operators. Boeing customers that have received the most 777s are Emirates, Singapore Airlines, United Airlines, ILFC, and American Airlines. Emirates is the largest airline operator as of 2018 and is the only customer to have operated all 777 variants produced, including the 200, 200ER, 200LR, 300, 300ER, and 777F. The 1777 was in a production line. A 300ER, said to be Emirates' 102nd 777, was unveiled off the factory on a ceremony in March 2012. A total of 1,416 aircraft, all variants, were in airline service as of 2018, with Emirates 163, United Airlines 91, Air France 70, Cathay Pacific 69, American Airways 67, Qatar Airways 67, British Airways 58, Korean Air 53, All Nippon Airways 50, Singapore Airlines 46, and other operators with fewer aircraft of the type. In 2017, 777 Classics are reaching their end of their mainland service with a 200 age ranging from 3 to 22 years. 43 Classic 777s, or 7.5% of the fleet, have been retired. Values of 777-200ERs have declined by 45% since January 2014. Faster than Airbus A330s and Boeing 767s, with 30% due to the lack of a major secondary market, but only with a few budget, air charters, and ACMI operators. In 2015, Richard H. Anderson, Then Delta Airlines chairman and chief executive said he had been offered 777-200s for less than US dollars 10 million. To keep them cost efficient, operators densified the 777s for about US dollars 10 million each, like Scoot with 402 seats in dual class 200s, or Cathay Pacific, which switched the 333 economy layout of the 777-200s to 343 seat to seat 396 on regional services. Orders and deliveries. Main article. List of Boeing 777 orders and deliveries. The 777 surpassed 2,000 orders by the end of 2018. Boeing 777 orders and deliveries by type. Total orders. Total deliveries. Unfilled. 777-200. Total orders 88. Total deliveries 88. Unfilled. None. 777-200ER. Total orders 422. Total deliveries 422. Unfilled. None. 777-200LR. Total orders 61. Total deliveries 61. Unfilled. None. 777-300. Total orders 60. Total deliveries 60. Unfilled. None. 777-300ER. Total orders 838. Total deliveries 833. Unfilled. 75. Total orders 777F 355. Total deliveries 278. Unfilled 77. 777X. Total orders 481. Total deliveries none. Unfilled 481. Total 2,305. Total deliveries 1,742. Unfilled 563. Orders and deliveries through January 2025. Boeing 777 orders and deliveries by year. 2015, 2016, 2017, 2018, 2019, 2020, 2021, 2022, 2023, 2024, 2025. Total 58 in 2015, 23 in 2016, 53 in 2017, 51 in 2018, 3 minus 3 in 2019, 10 in 2020, 53 in 2021, 68 in 2022, 100 in 2023, 62 in 2024, 2 in 2025. Total 2,306. Deliveries 200. Total 88. 200 ER. Total 422. 200 LR. 1 in 2019. 1 in 2021. Total 61. 300. Total 60. 300 ER. 79 in 2015. 88 in 2016. 65 in 2017. 32 in 2018. 19 in 2019. 4 in 2020. 7 in 2021. 3 in 2022. 1 in 2024. 833 total. 777F. 19 in 2015. 11 in 2016. 9 in 2017. 16 in 2018. 25 in 2019. 22 in 2020. 16 in 2021. 21 in 2022. 26 in 2023. 13 in 2024. 1 in 2025. Total 277. 777X. All 98 in 2015. 99 in 2016. 74 in 2017. 48 in 2018. 45 in 2019. 26 in 2020. 24 in 2021. 24 in 2022. 26 in 2023. 14 in 2024. 1 in 2025. Total 1742. 92, 94, 1995, 1996, 1997, 1998, 1999, 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010, 2011, 2012, 2013, 2014. Orders 112 in 1994, 101 in 1995, 68 in 1996, 54 in 1997, 68 in 1998, 35 in 1999, 116 in 2000, 30 in 2001, 32 in 2002, 13 in 2003, 42 in 2004, 153 in 2005, 76 in 2006, 110 in 2007, 39 in 2008, 30 in 2009, 75 in 2010, 194 in 2011, 75 in 2012, 121 in 2013, 277 in 2014. 200 deliveries 13 in 1995, 32 in 1996, 11 in 1997, 10 in 1998, 3 in 1999, 9 in 2000, 3 in 2001, 1 in 2003, 2 in 2004, 3 in 2005, 1 in 2007. 200 deliveries 48 in 1997, 50 in 1998, 63 in 1999, 42 in 2000, 55 in 2001, 41 in 2002, 29 in 2003, 22 in 2004, 13 in 2005, 23 in 2006, 19 in 2007, 3 in 2008, 4 in 2009, 3 in 2010, 3 in 2012, 4 in 2013. 200 LR 2 in 2006, 10 in 2007, 11 in 2008, 16 in 2009, 9 in 2010, 6 in 2011, 1 in 2012, 1 in 2013, 3 in 2014. Deliveries of 300. 14 in 1998, 7 in 1999, 4 in 2000, 3 in 2001, 6 in 2002, 9 in 2003, 2 in 2004, 4 in 2005, 1 in 2006. 300 ER. 10 in 2004, 20 in 2005, 39 in 2006, 53 in 2007, 47 in 2008, 52 in 2009, 40 in 2010, 52 in 2011, 60 in 2012, 79 in 2013, 83 in 2014, Sensen 7F, 16 in 2009, 22 in 2010, 15 in 2011, 19 in 2012, 14 in 2013, 13 in 2014. All 13 in 1995, 32 in 1996, 59 in 1997, 74 in 1998, 83 in 1999, 55 in 2000, 61 in 2001, 47 in 2002, 39 in 2003, 36 in 2004, 40 in 2005, 65 in 2006, 83 in 2007, 61 in 2008, 88 in 2009, 74 in 2010, 73 in 2011, 83 in 2012, 98 on 2013, 99 in 2014. orders through January 31st, 2025, and deliveries. Boeing 777 orders and deliveries, cumulative by year. Blue is for orders, green is for deliveries, through January 31st, 2025. Accidents and incidents. As of May 2024, the 777 has been involved in 31 aviation accidents and incidents, including a total of 8 hull losses, 5 in-flight accidents, resulting in 542 fatalities, including 3 fatalities due to ground casualties, along with 3 hijackings. The first fatality, involving the twin jet, occurred in a fire while the aircraft was being refueled at the Denver International Airport in the United States on September 5, 2001, during which a ground worker sustained fatal burns. The aircraft, operated by British Airways, sustained fire damage to the lower wing panels and engine housing. It was later repaired and returned to service. A laboratory replication of ice crystals clogging the fuel oil heat exchanger on a Rolls-Royce Trent 800 engine from the Air Accidents Investigation Branch (AAIB) report on the British Airways Flight 38 BA38 and Delta Airlines Flight 18 DL18 incidents. The first hull loss occurred on January 17, 2008, when a 777-200ER with Rolls-Royce Trent 895 engines flying from Beijing to London as British Airways Flight 38 crash-landed approximately 1,000 feet, that is 300 meters, short of Heathrow's airport runway 27L and slid into the runway's threshold. There were 47 injuries and no fatalities. The impact was severely damaged the landing gear, wing roots, and engines. The accident was attributed to ice crystals suspended in the aircraft's fuel clogging of the fuel oil heat exchanger (FOHE). 2 other minor momentary losses of thrust with Trent 895 engines occurred later in 2008. Investigations found that these were also caused by ice in the fuel clogging the FOHE. As a result, the heat exchanger was redesigned. The second hull loss occurred on July 29, 2011, when a 777-200ER scheduled to operate an Egypt Air Flight 667 suffered a cockpit fire while parked at the gate at Cairo International Airport before its departure. The aircraft was evacuated with no injuries, and airport fire teams extinguished the fire. The aircraft sustained structural, heat smoke damage and was written off. Investigators found a possible short circuit between the electrical cable and a supply hose in the cockpit crew oxygen system. 9M MRO. The aircraft involved in the disappearance of Malaysia Airlines Flight 370. The third hull loss occurred on July 6, 2013, when a 777-200ER operating as Asiana Airlines Flight 214 crashed while landing at San Francisco International Airport after touching down short of the runway. The 307 surviving passengers and crew on board evacuated before fire destroyed the aircraft. 2 passengers who had not been wearing the seat belts were ejected from the aircraft during the crash and were killed. A third passenger died 6 days later as a result of the injuries sustained during the crash. These were the first fatalities in a crash involving a 777 since its entry into service in 1995. The official accident investigation concluded in June 2014 that the pilots committed to 20 to 30 minor to significant errors in their final approach. Deficiencies in the Asiana Air's pilot training and Boeing's documentation of complex flight control systems are also cited as contributory factors. The fourth hull loss occurred on March 8, 2014, when a 777-200ER carrying 227 passengers and 12 crew en route from Kuala Lumpur to Beijing as Malaysia Airlines Flight 370 were reported missing. Air traffic control's last reported coordinates for the aircraft were over the South China Sea. After the search for the aircraft began, Malaysia's Prime Minister, Najib Razak, announced on March 24, 2014, that after analysis of new satellite data, it was now to be assumed that beyond reasonable doubt that the aircraft had crashed into the Indian Ocean and there were no survivors. The cause remains unknown, but the Malaysian government in January 2015 declared it an accident. US officials believe that the most likely explanation to be that someone in the cockpit of Flight 370 reprogrammed the aircraft's autopilot to travel south across the Indian Ocean. On July 29, 2015, an item later identified as a flaperon from a still missing aircraft was found on the island of Reunion in the West Indian Ocean, consistent with having drifted from the main search area. The fifth hull loss occurred on July 17, 2014, when a 777-200ER bound for Kuala Lumpur from Amsterdam as Malaysia Airlines Flight 17, MH17, was shot down by an anti-aircraft missile while flying over East Ukraine. All 298 people, 283 passengers and 15 crew on board were killed, making this the deadliest crash involving the Boeing 777. The incident was linked to the ongoing war in Donbas. On the basis of the Dutch Safety Board and the Joint Investigation Team official conclusions of May 2018, the governments of Netherlands and Australia hold Russia responsible for the deployment of the Buk missile system used in shooting down the airliner from a territory held by pro-Russian separatists. The sixth hull loss occurred on August 3, 2016, when a 777-300 crashed while landing and caught fire at Dubai airport at the end of its flight as Emirates 521. The preliminary investigation indicated that the aircraft was attempting a landing during active wind shear conditions. The pilots initiated a go-around procedure shortly after the wheels touched down onto the runway. However, the aircraft settled back onto the ground, apparently due to late throttle application. As the undercarriage was in the process of being retracted, the aircraft ran on its rear underbody and engine nacelles, resulting in a separation of one engine, loss of control, and subsequent crash. There were no passenger casualties with 300 people on board, but one airport fireman was killed fighting the fire. The aircraft's fuselage and right wing were irreparably damaged by the fire. The seventh hull loss occurred on November 29, 2017, when a Singapore Airlines 777-200ER experienced fire while being towed at Singapore Changi Airport. An aircraft technician was the only occupant on board and it was evacuated safely. The aircraft sustained heat damage and was written off. Another fire occurred on July 22, 2020, when Ethiopian Airlines 777F fell at the cargo area of the Shanghai Pudong International Airport. The aircraft sustained heat damage and was written off as the eighth hull loss. Mere reports on legal proceedings attribute the fire to the ignition of chlorine dioxide disinfection tablets at high temperatures in a humid environment on ground. On February 20, 2021, a 777-200 operating as United Airlines Flight 328 suffered a failure of its starboard engine. The cowling and other engine parts fell over a Denver suburb. The captain declared an emergency and returned to land at Denver Airport. An immediate examination, before any formal investigation, found that two fan blades had broken off. One blade had suffered metal fatigue and may have chipped another blade, which also broke off. Boeing recommended suspending flights of all 128 operational 777s equipped with Pratt & Whitney PW4000 engines until they had been inspected. Several countries also restricted flights of PW4000 equipped 777s in the territory. In 2018, similar issue occurred on United Airlines Flight 1175 from San Francisco to Hawaii, involving another 777-200 equipped with the same engine type. On May 21, 2024, a Singaporean Airlines Flight 321, operated by the 777-300ER, encountered severe turbulence over Myanmar and injured 104 passengers and crew, and it led to the death of a passenger who died of a suspected heart attack. Aircraft on display. The first prototype, a Boeing 777-200 BHNL EX N7771, was built in 1994 and originally used by Boeing for flight testing and development. In 2000, it was sold to Cathay Pacific, as no delivery slots were available for the newly built 777s, and was refurbished for passenger service. After 18 years of commercial service, BHNL was retired in May 2018 and press reports that it was to be displayed at the Museum of Flight in Seattle. On September 18, 2018, Cathay Pacific and Boeing announced that the BHNL would be donated to the Pima Air and Space Museum near Tucson, Arizona, where it would be placed on permanent display. Three retired Saudi 777-200ER aircraft, formerly registered HZAKG, HZAKK, and HZAKP, respectively, were transported by road from Jeddah to Riyadh in September 2024 to be displayed at the Riyadh Season Exhibition. The fuselage of each aircraft were to be used as a tourist attraction, featuring aviation-themed exhibits and/or dining and retail options. The 777 prototype BHNL REX N777-1 on display at the Pima Air and Space Museum after 6 years with Boeing's test fleet, followed by 18 years of commercial service. Specifications. Boeing 777 specifications. Variants: first generation, second generation. Model: 777-200 or 200ER, 777-300, 777-300ER second generation, and 777-200LR, 777F in the second generation. Cockpit crew: 2. 3 class seats: 305, 204F, 54J, 227Y for the 777-200 200ER, 368, 30F, 84J, 254Y for the 777-300, 365, 22F, 70J, 273Y for the 777-300ER, 301 seats, 16F, 58J, 227Y for the 777-200LR or 777F. 2 class seats: 313 for the 777-200 200ER, 396 for the 777-300 and 777-300ER, 317 for the 777-200LR, 777F. Exit limit: 440 for the 777-200 200ER, 550 for the 777-300 and 777-300ER, and 440 for the 777-200LR and 777F. Length: 209 feet 1 inches, that is 63.73 meters for the 777-200 200ER, 242 feet 4 inches, that is 73.86 meters for the 777-300 and 777-300ER, 440 for the 777-200LR or 777F. Wingspan: 199 feet 11 inches, that is 60.93 meters, and 31.6 degrees wing sweep for the 777-200ER and 777-300, and 212 feet 7 inches, that is 64.80 meters, or 31.6 degrees wing sweep for the 777-300ER and 777-200LR or 777F. Wing area: 4,605 square feet, that is 427.8 meters square, that is 8.68 AR for 777-200 200ER and 777-300. 4,702 square feet, that is 436.8 meters square, or 9.61 AR for the 777-300ER and 777-200LR or 777F. Tail height: 60 feet 9 inches, that is 18.5 meters for the 777-200 200ER, 60 feet and 8 inches, that is 18.5 meters for the 777-300 and 777-300ER, 61 feet 1 inches, that is 18.6 meters for the 777-200LR and 777F. Fuselage width: 220 feet 4 inches, that is 6.20 meters. Cabin width: 19 feet and 3 inches, that is 5.86 meters. The seats are 18.5 inches, that is 47 centimeter, at 9 abreast, 17 inches, that is 43 centimeters, and 10 abreast. Cargo volume 5,330 cubic feet, that is 150.9 meters cubed for the 777-200 or 200ER. 7,120 cubic feet, that is 201.6 meters cubed for the 777-300 and 300ER. 5,330 cubic feet, that is 150.9 meters cubed for the 777-200LR and 777F. M2 545,000 pounds, that is 247,200 kg. 200ER 656,000 pounds, that is 2,907 555 kg. That is for the 777-200 and 200ER. 600,000 pounds, 299,370 kg for the 777-300. 775,000 pounds, that is 351,533 kg for the 777-300ER. 766,000 pounds, that is 347,452 kg. 777F 766,800 pounds, that is 347,815 kg. OEW 299,550 pounds, that is 135,850 kg. 200ER 304,500 pounds, that is 138,100 kg for the 777-200 or 200ER. 353,800 pounds, that is 160,530 kg for the 777-300. 370,000 pounds or 167,829 kg. 300ER SF 336,000 pounds or 152,000 kg. The 777-300ER 320,000 pounds, that is 145,150 kg. 777F 318,300 pounds, that is 144,379 kg for the 777-200LR or 777F. Fuel capacity 31,000 US gallons, that is 117,340 liters, or 207,700 pounds, that is 94,240 kg. 200ER to 300 for 45,220 US gallons, that is 171,171 liters, or 302,270 pounds, that is 137,460 kg for the 777-200 200ER and the 777-300. 47,890 US gallons, that is 181,283 liters, or 320,863 pounds, that is 145,530 kg. The 777-300ER and the 777-200LR or 777F. Ceiling 43,100 feet, that is 13,100 meters. Speed max Mach 0.87 to Mach 0.89, that is 499 to 511 kn, or 924 to 945 kilometers per hour, or 574 to 587 miles per hour. Cruise Mach 0.84, that is 462 kn, or 892 kilometers per hour, or 554 miles. Range 5,240 nmi, that is 9,700 kilometers, or 6,030 miles. 200ER 7,065 nmi, that is 13,080 kilometers, or 8,130 miles. For the 777-200 or 200ER, 10,600 feet, that is 3,230 meters. For the 777-300, 10,000 feet, that is 3,050 meters. For the 777-300ER, 9,200 feet, that is 2,800 meters. 777F, 9,300 feet, that is 2,830 meters. For the 777-200LR or 777F, engine 2X, PW4000, Trent 800 or GE90 for the 777-200 or 200ER, PW4000, Trent 800 for the 777-300, GE90 115B, GE90 110B or 115B for the 777-200 LR or 777F. Max thrust 2x, 77,200 lbf, that is 343 kN. 200 ER, 93,700 lbf, that is 417 kN. 98,000 lbf, that is 440 kN, plus 777-300. 115,300 lbf, that is 513 kN, for the 777-300 ER. 110,000 to 115,300 lbf, that is 777-200 LR or 777F, that is 489 to 513 kN. ICAO designation B777-2, the 777-2 200ER, B777-3 for the 777-300, B777W for the 777-300ER, and B777L for the 777-200LR or 777F. For Boeing 777-8 and 9 specifications, see Boeing 777X. Diagram of Boeing 777 variants with front cross-section, side and top views. 777-200ER on left, 777-300ER on right. See also competition between Airbus and Boeing, aircraft of comparable role, configuration and era. Airbus A330, wide-body twin-engine jet airliner. Airbus A340, wide-body long-range quad-engine jet airliner family. Airbus A350 XWB, wide-body long-range twin-jet airliner family. Boeing 767, wide-body twin-jet airliner family. Boeing 767 Dreamliner, Boeing wide-body jet airliner introduced in 2011. Yushin 1296, Russian long-range wide-body airliner. McDonnell Douglas MD-11, wide-body airliners developed from the DC-10. Related lists. List of Boeing 777 operators. List of Boeing 777 orders and deliveries. List of Boeing 777X orders and deliveries. List of Boeing customer calls. List of commercial jet airliners. List of civil aircraft. Aviation portal. United States portal. This sound file and all text in the article are licensed under the Creative Commons Attribution Share Alike 4.0 International License, available at creativecommons.org/licenses/by-sa/4.0.